Okay, so expected value. So what is expected value? Expected value is it's when like you are either gambling or playing in a raffle, where there's some probability involved, and you want to know what the expected outcome is going to be. So on average, are you going to win money or are you going to lose money on average each time you play? So let's see what it says here. People use expectation to make decisions in many different areas. For example, expectation is used in business to predict future profits of a new product. In the insurance industry, expectation is used to determine how much each insurance policy should cost. So there's a whole field called actuary. If you're an actuary, that means you kind of assess how much insurance policies should cost based on probability of risk. So like, for example, if you're going to give an insurance policy, a car insurance policy to a young person, like a teenager, that insurance is going to be more expensive because there's a higher risk involved with young people driving versus older people. So that's just an example. Should cost for the company to make an overall profit. Expectation is also used to predict the expected gain or loss in games of chance, such as lottery, roulette, craps, and slot machines. So the formula, let's go over the formula. All right, the formula for that is going to be the probability of winning, or let's just say the amount you win times the probability that you win. Oops. Plus the amount that you would lose times the probability that you lose. So that's the formula. It's the amount that you win times the probability that you win plus the amount that you lose times the probability that you lose. So let's take a look at this very first example. It's a game and you have a 2% chance of winning, $94, and a 98% chance of losing. Notice that the percentages add up to 100. That should always be the case. The probability that you win plus the probability that you lose should always equal 100. And you would lose $8 if you play this game and you lose, and you would win $94. But of course, you have a smaller probability of winning than you do of losing. In the amount, in the amount row, this is the amount row, write in the dollar amount of that you will win or lose respectively. So I think they meant to say that you will win or lose respectively. So we already know, it tells you in the problem how much you would win. The amount that you would win is $94, right? So that goes there. What the amount that you would lose would be $8. But in math, you have to make that a -8 because you're losing 8. So you have to make sure that you include that negative sign for a loss. For a win, it's positive. For a loss, it's always negative. All right, so what's the probability that you win? Well, they tell you what the probability of winning is. It's 2%. So we have to convert that percent to a decimal. So that would be, does anybody know? 0.02. That's 2%. And then the probability that you lose is 0.98. All right, so now we can plug it into the expected value formula. All right, so let's figure out what the expected value. So this is the way they label expected value. The expected value of, we'll just call it X. The expected value of X is the amount that you win, that's $94, times the probability that you win, 0.02, plus the amount that you lose, -$8, times the probability that you lose, 0.98. All right, so there it is. That's your formula for expected value. This is going to tell you how much you should expect to win or lose in this game. So let's plug this into our calculators. So I'm going to do that now with my calculator. I'll share my calculator screen so you can see how I plug that in. All right, so it should be 94 times 0.02 plus -8. Careful not to use a subtraction for negative. For negative, you have to use this button, which is then it's negative with the parentheses around it. -8. Our offset calculator will give you an error. Times 0.98 equals, there it is. So on average, this game you would lose because it's a negative number. The negative means that you're going to lose on average $5.96 every time you play this game. So this would not be a game worth playing if it's not for charity or for a good cause. If it's just for gambling purposes, I would say don't play this game because the game is not it's not stacked in your favor. You're going to lose on average $5.96. But if it's for a raffle, for a good cause, of course you want to, contribute. Okay, so that's that. Let's go ahead. We are going to lose on average. Was it 96 cents or 98? I think it was 96.
96.
Yeah. So it says, explain what this value means. It means on average, you will lose $5.96 because it's a negative number. If it was a positive number, then you would win. But since it's negative, you're going to lose on average. All right. So it's not, doesn't mean that you're going to, this is how much you're going to lose every single time. It just means if, let's say you play this 100 times, maybe sometimes you win, sometimes you lose, but on average, if you were to average out all the amounts that you win and lose at the end of the day, the average is going to be negative $5.96. All right, so that's how you that's how you find expected value. Let's look at the next one. Kevin estimates that there is a 60% chance that he will make $80,000 and a 40% chance that he will lose $20,000. Find his expected value. Once again, the percentages of winning and losing should add up to 100%, which they do. 60 plus 40 is 100. All right, so anybody know how much he would profit if he wins?
$80,000.
Yeah, it's a lot of money, 80,000. And the probability that he wins is
0.60.
0.60. That's a high probability. I would play this game in a heartbeat. All right. The amount that this Kevin guy would lose is 20 grand. Oh, I don't know if I would play. Never mind. I wouldn't play in a heartbeat. No, I forgot that there is a high probability of losing $20,000. This would be a very risky game, but it is in your favor because it's a higher chance of winning than there is losing. But still, if I were a rich person, then I would play this. Okay, 0.40. All right, so let's figure out what the expected value is. So expected value is equal to the amount that you win times the probability of winning plus the amount that you lose. Don't forget, I'm forgetting something. Anybody see what I'm forgetting here?
Plus.
Well, I got
Plus,
the plus here, but there's a little minor thing that I'm missing.
Oh, wouldn't it be 80,000?
Negative.
Oh, yeah. So it'd be
Yeah,
minus 20.
minus.
yeah, because you're losing 20,000, so you have to make that negative. All right, and the probability of losing is 40% chance. So let's see what the expected value is on average. If you were to play this game many times on average, let's see what the outcome would be. So let me share my calculator. You guys can do this as well on your calculators, so you get used to it.
I came up with 40,000, Professor.
40, all right. 80, 1, 2, 3 times 0.6 plus negative 20,000 times 0.4 is, yeah, you're right, 40,000. So this would be a great, these odds would be in your favor to play this game, but kind of a game. They would have the game probably if the percentages were reversed. If the
It seemed like a high stakes poker type of game.
Yeah, I agree. Oops, $40,000. All right. Cool. All right, so that's how you figure out expected value. Now let's look at expected value of gain or loss. The expected value is used exclusively of games of chance, insurance, and an area of application called decision theory. I'm not really familiar with decision theory. Let's look at the following two examples and calculate the expected value of gain or loss. A ski resort loses $70,000 per season when it does not snow very much and makes a $250,000 profit when it does snow a lot. The probability that it will snow at least 75 inches, which is a good season, is 40%. So let's use the following table to guide you, find the expected value for the profit and explain what it means. All right, so for a good season, what's the amount that they would make?
$70,000.
250.
Yeah, so when it does snow a lot, it's,
Oh,
Two.
yeah, that's right. That's right.
yeah, for a good season. For a bad season, it's going to be
70,000.
70,000. Negative.
Negative.
Yeah, it's going to be negative. Yeah, because it says here loses. That means negative. Okay. And then we have to find the probabilities. Do they tell us? Yeah. What's the probability of a good season?
40% or 0.40.
Yeah, it tells you a good season, the probability that it will snow 75 inches is 40%. So 0.40. So does anybody know what that means in terms of the probability that there's not a good season?
0.60 because they have to equal up to 100.
You got it. They have to equal 100%. So it has to be, even though they don't tell you, but you should be able to conclude that it is 60% because they have to add up to 100. All right. So now we can use the formula. The formula says, okay, so expected value is going to equal to 250 times 0.40 plus negative 70,000 times 0.60. All right, I'm going to do it on my calculator. You guys let me know what you get, and I'll let you know what I get. All right, anybody get an answer yet?
58,000.
Yeah, that's what I got, 58,000. So it looks like regardless if there's a good season or a bad season, it looks like overall they're going to be okay. They're not going to make as much as they would like if there's a lot of bad seasons, but on average, they're going to make a profit because it's positive. All right, what would it mean if the expected value was 0? Anybody know what that would mean? What if this answer was 0? Well, that just means that on average, the ski resort would need neither make a profit nor lose money. They would break even. They would break even. So they wouldn't make money, but they wouldn't lose money. So that's what the 0 would mean. So all right, so I'm gonna give you guys a little bit of time to see if you guys can do the next one on your own. So let's take like 5 minutes to see if you guys can try this example out, and then we'll come and check your answers. So I'm gonna give you guys 5 minutes. All right, so just in case you didn't see that, the answer to the number 2 was 21,800. All right, let's go to this one. A life insurance company charges a 23-year-old male premium of $300 for 1 year, 100,000 life insurance policy. A 23-year-old male has a 0.9975 probability of living for a year. What is the expected value for the insurance policy? All right, so this is also used for calculating premiums for insurance policies on people. All right, what's the amount that he will live? Let's see. This is let's see. Well, let's look at if he dies, how much money will be given out?
$100,000.
Yeah, looks like $100,000 will be given out if this person dies. So 100,000, but okay, so positive though, right? Because it's gonna be like a
Yeah, it's gonna be a payout versus it's
yeah,
gonna be given to whoever the policy holder is versus them giving that money to the insurance company.
yeah, exactly right. Okay, and the beneficiary will get that, and
Mhm.
for if the person lives, is it gonna be a positive number or a negative number?
They're gonna, wouldn't it be negative 300 because that's how much he's paying a month?
Exactly right. This person is paying $300 a month for insurance policy. So that's a negative because if he lives, he's not going to get that money back. He has to pay that premium. So that's true. Very good. All right. And then let's see. Now we have to look at the probabilities. Well, what's the probability that this person lives a year?
0.9975.
Yeah, that's probability of living. 0.9975. And then we have to figure out what the probability of this person dying is. Does anybody know how to find that? They have to add up to 1, right?
0.0025.
Yeah, how did you get that?
I subtracted a 1 minus 0.9975, so that gave me 0.0025.
Perfect. That's exactly how you're supposed to do it. Good. You're supposed to figure out the probability of dying by subtracting this number from 1, and that gives you the number. So if you add them, it should equal 1, which is equivalent to 100%. All right, very good. All right, so we got that. Now we can figure out the expected value. So let's go ahead and use the formula. I'll put this over here. All right, so the expected value formula is, we already know, the probability that he lives. It doesn't matter which one you put first, as long as you put these two, that one times that one, plus that one times that one, but it can be in any order. So I'll put this one first. Probability that he lives times the probability of living, plus the amount that the payout is, times the probability of dying, and whatever that turns out to be. So let's work it out.
Mr. Hernandez, are you recording?
49.25. He is.
Yeah.
Yes, yeah, I'm recording, yes. So,
Okay,
all right, negative 300 times 0.9975 plus 100.
I got negative 49.25.
Yeah, you're right. I got the same thing. So I'm getting negative 49.25, which I'm gonna write what that means. On average, what's his name? Oh, there's no name. I'll just say he is expected to lose $49.25 per year. Because this is a policy, yeah, this is based on a year. So,
So realistically, even though, let me just make sure I'm understanding, even though he's paying $300 a month, and then the policy is worth $100,000, they're taking like maybe that negative $49 is what they're putting to the side to go towards the payout.
no, the way I'm interpreting this is that, say there's like 1,000 people buying this insurance policy. The insurance company is making money because out of the 1,000 people, maybe like 3 of them die. And so they have to pay out $300,000, right? But the rest of them are going to survive, which means that they're going to get a lot of money from the $300 premium that they're collecting every year from all these other people that are surviving. So on average, the company is going to make $49.25 per person. Yeah, but the person that's paying for the premium, I'm sorry, for the insurance, this 23-year-old is losing $49 on average. Yeah, that's the way I interpret this problem. So on average, the 23-year-old is losing this much per year, but the insurance company is actually making $49.25 per person per year. So yeah, it's just based on a lot of people buying this premium, this insurance policy, and that's how the insurance companies make a profit. So that's why they're in business, because if they're not, of course, they're not going to do this out of the goodness of their hearts. They're trying to make, it's a business, so they're trying to make money. So yeah, let's look at the next one. For an outdoor concert of the Los Angeles Philharmonic Orchestra at the Hollywood Bowl, concert organizers estimate that 14,000 people will attend if it is not raining. If it is raining, concert organizers estimate that 8,400 people will attend. All right, so if it is raining, all right, if it's not raining, you have a lot more people, right?
Right.
If it is raining, then you have less people, which makes sense. On the day of the concert, meteorologists predict that there's a 70% chance of rain. Determine the expected number of people who will attend this concert. So let's focus on if it rains. How many people do we expect at this concert if it rains?
4,000. 8,400, sorry.
8,400, right? If it rains. Yeah, if it is raining, 8,400. All right, if it's not raining, how many people should attend, are expected to attend?
14,000.
14,000. And the probability that it rains, according to the meteorologist, is
70,000.
0.70.
0.70.
0.70, which means we should be able to figure this out, right?
0.30.
0.30. Once again, 1 minus 0.70 is 0.30. All right, so, oh, I think okay. Do I need a negative here? Let's see.
It's a negative 8,400.
If it rains, I'm wondering, is it going to be? Because that would mean that negative, yeah, I don't think that should be right, because that would be negative 8,400 people attend. That doesn't make sense. So I think in this case, we don't put a negative. Let's just see what happens. So according to this formula, the expected value of people should be in between these two numbers, right? It should be somewhere in the middle, like maybe in the middle, maybe like what's some number in between? Maybe like 12,000 people or 10,000 people. It's got to be bigger than this and less than this. So let's see what the outcome is if we just leave it positive. So 8,400 times 0.70 plus 14,000.
10,080 people. So that number's between those two numbers.
Perfect. All right, so that makes sense. So 0.70 plus 14,000 times 0.3. Yeah, you're right. It is 10,080 people are expected to show on average. Yeah, which makes sense because the number should be in between those two, which it is. All right, let's see if there's another problem here. Is that the last one? Yeah, that's the last one because this is the same thing. So this is the last problem. So I'll give you guys a little bit of time again to try this problem out. And yeah, and then so go ahead and take a couple minutes to try. Okay, this one's a little bit different just because it has a little extra. It says here that there's a chance of breaking even. So let's see how that changes the problem. So I'm going to create a table. Okay, so let's see. All right, it says the Triple L Investment Club is considering a certain stock. After considerable research, the club members determined that there's a 60% chance of making a $10,000 profit. So I'm just going to put profit here. A 10% chance of breaking even. So breaking even. And a 30% chance of losing.
Mhm.
All right, and over here, we'll just put amount and probability.
Mhm.
All right, so what's the what would be the profit?
So the
amount?
profit is 10,000 and the probability is 0.60.
Okay, 10,000, probability is 0.60.
Breaking even is 0 because you won't lose, you won't gain or lose. It'd be $0, and then that's 10.10.
Yeah, very good. That is right. $0 because you're not going to win or lose.
And then losing is 7,200, and then that's 0.30. And all
Yeah.
those numbers make 100.
Yeah, you do want to make sure that it adds up to 1, which is 100%. Very good. So that's good. All right, and so now the expected value formula is the same
So
thing.
I
Yeah.
plugged it into my calculator as 10,000 times 0.60 plus 0 times 1 plus 0 times 0.10
Mhm.
plus negative 7,200
Yeah, we forgot the negative. Right?
times 0.30.
Yeah, exactly right. Don't forget the negative for the losing. So negative 7,200 times 0.30.
And I got 3840.
All right. All right, perfect. So let me just see if I get the same thing. Yeah, 3840 is what I'm getting. So this is a positive number, which means that on average, they're going to win. They're going to win or make a profit on average. So yeah, on average, the company or the club will make $3,840,000. Perfect. All right.
Mr. Hernandez,
Yes.
can you go up a little bit more to the top, please?
Like right there.
Okay, is the 14,000 right there supposed to be negative or no?
No, for this one, it was a little different because we were dealing with people, not money. So you can,
Oh,
yeah, you can have negative people, but you can have
okay.
you can have a negative amount of money, but not a negative amount of people. So yeah, in this
Oh.
case, it was not.
Okay, and also, can I talk to you after class, please?
Yeah, that's fine.
Okay, thank you.
All right, so let's take a break and then after the break, we'll do maybe a couple homework back. Let's take a look at 11.3 homework. You'll see I clicked on it already. Let's go over number 15. So 15 says roll a die. Alyssa and Gabriel play the following game. Alyssa rolls a die. If she rolls a 1, 2, or 3, Gabriel gives Alyssa $3. If Alyssa rolls a 4 or a 5, Gabriel gives Alyssa $2. However, if Alyssa rolls a 6, she gives Gabriel $14. So let's look at Alyssa's expected value, basically. So I would recommend that you set up a table. And then there should be, let's see, how many columns would there be? There's how many probabilities are involved? 1, 2, or 3, that's one
It's 3
probability.
probabilities.
Yeah, a 4 or 5, that's 2 probabilities. And then a 6, that's 3 probabilities. So you want 3 columns in your table. So create a table with 3 columns and then the amount and the probability. So that's 2 rows. And then fill in all the boxes and then you can fill up, and then you can set up your equation and then we'll see if you get it. So I'll give you guys a little bit of time to do that in a breakout room. So let me get you guys going in a breakout